Hello and what's up to you all great 10 Mindsetters. It is a lovely Monday and a new term. Welcome. I hope you enjoyed your holidays. If you were studying, well, I hope you had a great study session. But otherwise, if you were on holiday, it is that time where you pick up your books again and start studying. Here I am. My name is Abram and I'm here to give you a great lesson with Natasha. How are you, Natasha?
I'm very well, thanks. Great to be back, guys, and hope that you're all ready to work in this new term, even though we're only back for a little while.
Very short also.
Very short.
Did you have a holiday?
I did not have a holiday. No
Don't
rest
worry,
for the
you're
wicked.
not alone. You're not alone. There are some mindsetters that were also busy during the holidays for some other people. But otherwise, you're gonna share with that. You're gonna share that with me on Facebook and let me know how were your holidays. Very short also, but I hope you're working so hard. Today, what are we doing, Natasha?
Okay, grade 10s. Today we're looking at trigonometry in triangles. We're going to revise some of the trigonometric ratios that you guys have learned and solve a few triangles as well.
Awesome. This is what you need to do, Mindsetters. Log on to facebook.com/learnextra. Like the page, share the page with everybody, and tell them to join the crew, the family that learns more and learn extra. Otherwise, follow us on Twitter @learnextra. I'll read some of your tweets during the show. Remember, you can ask your questions, help other Mindsetters also, because that's the spirit of Mindsetters. Otherwise, you can also download your notes on the link that I'll post on Facebook, but our website is learn.mindset.co.za. We have two options just to help you Mindsetters. We have a viewing option where you can view the notes for everyone. Whether you're using a smartphone or not a smartphone, you can still view the notes if you're on internet. And otherwise, we have a download option, which is option number 2, where it takes you straight to the notes and you can just download them instantly, just like that. So let the learning begin.
Okay, great. Thank you so much. And guys, I hope you're ready for this term and you're ready to get stuck in. We have a lot of holidays this term, but remember there's still a lot of work to get through. Okay, so firstly, just a reminder of your challenge question for today. We're looking at trigonometry. Okay, so this is your question. You can have a go. Let's see if any of you get the answer. You've got the point A is -3 and 4. That's a point on the Cartesian plane. And they say with the use of a diagram and without a calculator, very important that they say without a calculator, determine A, sine theta, B, tan theta, C, sec theta, and then D, we're looking at sine squared theta plus cos squared theta. So guys, let's see if you're up to the challenge. Let's see if you can do this, putting together all of the knowledge that you've possibly learned so far. If not, don't worry, we're going to go through all of this work in the lesson and hopefully you'll get to a point where you can answer this kind of question. Okay. Now guys, just a reminder of some basic uses of trigonometry, well, some rather important uses rather, not just basic uses. And what I want you guys to remember is as we go through the lesson and you start solving triangles, you sort of lose focus of what is it all for? Why are we studying trigonometry? Well, trigonometry is one of the really interesting sections in maths that's used over and over again in every single day real life. Now, trigonometry comes from the Greek word trigonon, meaning triangle, and metron, meaning measure. So really, when we're looking at trigonometry, we're measuring triangles. We're interested in the angles, we're interested in the sides of the triangles, and very importantly, you can find the heights of massive mountains and all sorts of things using trigonometry and using similar triangles. Similar triangles, some things that you guys would have done in grade 9. So trigonometry, really, there's so many everyday applications, and if you want to become land surveyors, engineers, astronomers, anything like that, you're going to need trigonometry. So some of the everyday uses of trigonometry, it's commonly used to find the heights of towers or of mountains, as you can see in the picture below. And mountains are measured by land surveyors, and they will use trigonometry and a theodolite in order to get the height of a very, very large mountain. So it's quite interesting to see how that works. It's also used in navigation to find the distance of the shore from some point at the sea. And it's also used in astronomy to find the distance between celestial bodies. Now that's quite massive. I mean, imagine those distances are really, really big. And with trigonometry and similarity of triangles, you can actually find the distance between different types of bodies in the sky. Absolutely amazing. So maths, as always, very interesting, very fascinating. But in order to be able to do all those exciting things, you obviously need to know all your basics. You need to remember your trigonometric ratios. So let's go over those. The things that we'll be using in this lesson. Sine of alpha is opposite over hypotenuse. So you guys will also have it written down at some point as SOHCAHTOA. This is what helps you to remember the ratios. So sine of alpha is opposite over hypotenuse, and cos of alpha is adjacent over hypotenuse. Tan of alpha is opposite over adjacent. So SOHCAHTOA. Okay, that's what we use, a little mnemonic to remember the ratios. So sine opposite over hypotenuse, cos adjacent over hypotenuse, and tan is opposite over adjacent, always with reference to some angle. All right? Now, cosec of alpha is the reciprocal ratio or the inverse of sine alpha. So cosec, we're going to basically flip it over the same ratio. So we know that because they're reciprocal, sine of alpha times cosec alpha is equal to 1. So really what we're saying is that then cosec of alpha is going to be equal to 1 divided by sine alpha, just simply by dividing both sides by sine alpha. So if I want to look for an expression for cosec alpha, well, I know that cosec is 1 over sine alpha, and we know that sine is opposite over hypotenuse. So 1 divided by opposite over hypotenuse, that's what we do, fractions, invert, and multiply. So it becomes 1 times hypotenuse over opposite. So therefore cosec of alpha is hypotenuse over opposite. Okay, so that's our ratios there. Sine of alpha is opposite over hypotenuse. Cosec of alpha would be the inverse ratio, so it's hypotenuse over opposite. We've just swapped them around, as you can see. Cos of alpha is adjacent over hypotenuse, and sec, being the inverse operation of cos, is going to be hypotenuse over adjacent. Tan of alpha opposite over adjacent, so therefore it stands to reason that its reciprocal ratio, cot of alpha, would be the opposite thing. So it would be, or the inverse thing, it would be adjacent over opposite. Okay, so those ratios, guys, those are the basic ratios that you need to know. In order to do any kind of trig, any kind of advanced trig, you need to know these basic ratios, and we're going to keep on coming back to these. So make sure you understand how to use all of these ratios. What I also want to do while we're discussing ratios is just link it back, because sometimes, remember, you're working on a Cartesian plane and you need to draw triangles in order to answer some of your questions. So I just want to give you a simple way to remember where opposites is the same as what? Is it the same as y? Is it the same as r? So we're going back to the definitions. We know that sine is opposite over hypotenuse, but in terms of y and r and x, what is it? Okay, so let's quickly go over that. So you guys know that sine of, let's call it theta, is equal to opposite over hypotenuse. Okay, and remember there we're talking about a 90-degree triangle. So you guys would obviously then identify your hypotenuse. Let's say theta is there. You would then identify your opposite side and your adjacent side to that angle theta. All right? So sine of theta is opposite over hypotenuse. But now, if we then had this superimposed on a Cartesian plane, so we have that kind of a thing, all right? And say that that's theta there. And we're going to call this, we know on the horizontal axis, that's all your x values. All your vertical values are your y. And then that's going to be your radius, okay, measured from the origin. So if I was looking for sine of theta in my triangle, sine is going to be opposite over hypotenuse, which gives me the same value as y over r. So sine of theta is opposite over hypotenuse, or y over r. Okay. Similarly, you'll get cos of theta is adjacent over hypotenuse, or it's the same as x over r, and then tan of theta is opposite over adjacent, which is the same as, so if you go back to your diagram, if you're looking at theta opposite over adjacent, it's going to be y over x. Okay, so what you will find is that when you're working with a triangle that you've drawn from some original points on your Cartesian plane, your y's, your x's, and your r's correspond with your opposites, adjacents, and hypotenuse. So your hypotenuse is the same thing as your radius. Your adjacent side, depending on where your angle is, of course, but your adjacent side is going to be, in this very simplistic case, it's going to be your x values, and then your opposite sides are going to be your y values. Okay, so you can always draw that triangle and then make the comparison between the two. So if you don't like working with opposite and hypotenuse, you can work with y and r. Okay, so it's just something to get used to, and just remember the two things are exactly the same. All right, and you will get the same ratios if you use the correct angle. Okay, all right, with that, I think it's time to take a quick break before we get into the questions for this afternoon.
Thank you so much, Natasha. And Mindsetters, I should remind you that during this break, we have a challenge question that is posted on facebook.com/learnextra. Give it a try, and we'll see the answer later on the show. Otherwise, keep your eyes peeled on the page and on your screens. See you soon. Welcome back, grade 10s. Now, I see on the page there are lots of mindsetters that are chatting with me. There's Homuto, there's Banyana, there's Apiwe saying, you know what, it is a new term, but the same old awesome mindset is back. That's true indeed, Apiwe. And otherwise, there's Hester also. A bit of sad news, but welcome back. I hope you're going to enjoy this term with us. But otherwise, Natasha, we have something new on, for our mindsetters, which we started last term. We have a Facebook app, which is our help desk. So mindsetters can also check the FAQs questions on the app, and also send us their questions on the app. So if they're on Facebook already, they can just send us through their questions, and we have a help desk that will help them.
Yeah,
isn't that cool?
Absolutely fantastic. I mean, apps, everything these days has something to do with an app. I mean, you really can't get away from that, hey?
So true.
Fantastic.
So true. I'll share the link with you, mindsetters. Otherwise, you can still send us your questions, and then later on, Natasha is going to answer you. Back to you, Natasha.
All right, great. Well, make use of that new app, guys. I suppose that's the way the world's going, hey? Technology. And imagine none of it would be possible without maths. Yes. What a great subject, hey? All right, so let's get into question 1. Using your definitions of trig ratios, I just want to remind you what we did just before the break. What I showed you guys, and which is a good way to remember your opposites, hypotenuse, x, y's, r's, etc. Opposites is the same as a y value. Adjacent is the same as your x value. Hypotenuse is the same as your r value. Okay, so those things are used interchangeably. All right, so we're going to use that for question 1, which says write down 2 solutions for each of the following trig ratios in terms of the sides of the triangles. Now, if you look at the diagram you've got triangle ABD, which is the big one, and I'm going to put this in a different color, so just bear with me. So I've got triangle ABD, which is the one in green. Okay. Then we also have triangle ABC, which I'm just going to go over here with the pink. We've got ABC. And let's move that across so you guys can see it's actually 2 triangles that you're looking at there. Okay. And then we've got triangle ACD. So there's so many different ratios that we can possibly get for all the different angles within these triangles. Because when I look at this, we've got 3 different triangles that we can work with. So we've got, okay, and that one's not quite a straight line, is it? There we go. Okay. Right, and then we've got the last one that I was talking about, ACD. Okay, guys, I've made it nice and colorful so you can easily see each of the different triangles that we need to be looking at, all right? Now, when they ask you about questions about finding answers for your trig ratios, you need to isolate that into a specific triangle. Because remember, depending on where that angle, specific angle is, in that specific triangle, your opposites and your adjacent sides are going to change. All right. So in any 90-degree triangle, in order to use your trig ratios, you need to identify what is your hypotenuse. So if I'm going to draw another triangle on the side here, that's 90 degrees. Remember, the side opposite your 90 degree will always be your hypotenuse, or your radius if you prefer. If we're looking from this angle here, theta, then the side adjacent to theta, that's not the hypotenuse, because obviously the hypotenuse can't change. The side that's not the hypotenuse, that would be your adjacent side to your angle. And then the side opposite your angle would obviously be your opposite side. So within your 90-degree triangle, the first thing you do is identify the hypotenuse, and then you can tell what's the adjacent and opposite thereafter. Remember, your hypotenuse, and you learned this long ago, hypotenuse will always be the longest side in a 90-degree triangle. Okay, so bear that in mind when we look for the ratio sine of angle B. Now you'll notice that angle B falls into two different triangles. It falls into the pink one, ABC, and then it also falls into the bigger green triangle, which is ABD. So one of the ratios for sine of angle B, all right, now I'm going to work with the big triangle first, the triangle in green, the triangle ABD. Your 90 degree is at angle A, so that's your 90 degree there, right? So once I've identified that as my 90 degree in the big triangle ABD, the hypotenuse is going to be side BD, all right? Now from angle B, which is the one I'm interested in at this point, in the big triangle, the green one, my opposite side is going to be AD, and my adjacent side will then obviously be the remaining one, the one adjacent to angle B that's not the hypotenuse, so that would be side AB. All right, so that's in the big green triangle. So if I want sine of angle B in the big triangle, it's going to be opposite over hypotenuse. So it's going to be AD over BD. Okay, but remember, we're looking for two ratios. So sine of angle B also falls into the little triangle in pink, which is triangle ABC. Now guys, over here, your angle, I'm going to use a different color. Let's see, let's use this orange. Your hypotenuse, or your 90 degree, is going to be opposite your hypotenuse, and your 90 degree here is at angle C. So therefore, now paying attention to all the orange that I'm going to write, and forgetting about the blue now, because now we're looking at triangle ABC, the little pink triangle. If C is 90 degrees, then the hypotenuse is going to be AB in that triangle, not for the whole big one, just in triangle ABC. And then your opposite side is going to be AC, and your adjacent side is going to be BC. Okay, I'm doing this one in a lot of detail so that you guys can understand what I'm doing going forward, but I'm not going to do each and every one in such a lot of detail. So just for you guys to understand how we get these different ratios. So sine of angle B in this little triangle ABC is going to be opposite over hypotenuse. So it's going to be AC over my hypotenuse, which is AB. All right, so we've got two ratios there for, or two answers for the ratio sine of angle B. We've got one in the big triangle, the big green triangle ABD. We've got our ratio of sine of angle B is AD over BD, and then sine of angle B in the little pink triangle ABC is AC over AB. All right. So what you want to do, because there's so many triangles, is identify your angle and then see which triangle it falls into and identify your hypotenuse and then work out your ratio from there. All right. Okay, so for part B, I'm going to take out all of the other writing that we've got so that we don't get so confused with all these arrows and all of that. Alright, I'm going to try and keep the writing in blue because that's going to stay the same regardless of which angle you swap around to within triangle ABD. Alright, so actually the next one we're looking at cos of D, so we're going to need to change that as well. Our opposite and our adjacent is going to change because remember now we're actually changing the point of reference. We're no longer at angle B, we're now looking for cos of D. So now we're going to this angle here. Your hypotenuse is going to stay the same regardless of where you are in the big triangle ABD, right? But your opposite side is now going to be the one directly opposite D, and then your adjacent side is right next to D in the big triangle, so it's going to be AD. Then if you look at what other triangle does angle D fall into, it also falls into this triangle ACD, the yellow one. So if we're looking in the yellow triangle, right, we know that our 90 degree is there at angle C, so therefore the opposite side, AD, is going to become the hypotenuse within your little triangle. So not within the big one, because AD in the big triangle is adjacent, but in the little triangle ACD, your AD is going to be your hypotenuse if we're looking from angle D, and then your opposite side is going to be AC. Alright guys, so you've got to be careful because you can see it looks quite tricky here. It depends on which triangle you're in, and it can get quite tricky if you've got a lot of triangles. So looking from angle D, I've got AC is opposite and AD is hypotenuse when we're working in triangle ACD, so therefore my adjacent will be CD. And you can see I've written this all on the inside of the triangle so as not to confuse it with the bigger outside triangle. Alright. So cos of D, here we're looking in the big triangle ADB. Cos we know is adjacent over hypotenuse from our SOHCAHTOA. So cos of D is going to be adjacent, which is AD, in the big triangle, over the hypotenuse, which is BD. And that's in triangle ABD. Then in triangle ACD, cos of angle D is going to be the adjacent angle to angle D, which we know, the adjacent side, sorry, to angle D, which we know is CD, over your hypotenuse, which is AD. Okay, so keep it separated, keep your triangle separated, and be careful when you're going from one angle to the next, because as you can see, your opposites and your adjacents are always going to change. Okay, I'm taking that off. Our hypotenuse stays the same, but now we're going back to angle B again. All right, so when we were at angle B for the first question, you saw that your opposite side in the big triangle was AD, and your adjacent side was AB. So that's in the big triangle ABD. In the little triangle, the pink triangle ABC, you had your hypotenuse in the little triangle as side AB. Okay, that was opposite your 90 degree. From angle B, your adjacent side was BC, and your opposite side was AC. All right. So one of the trig ratios for tan of B, working in your bigger triangle. So now from triangle ABD, tan of angle B is going to be your opposite side in your big triangle, which is AD, over your adjacent side, which is AB. So it's AD over AB. All right. And then working within the little triangle, tan of angle B. So now looking at triangle ABC, tan of angle B is going to be AC, which is opposite, and then over your adjacent, which is BC. So it's AC over BC. Okay. And those are your two different ratios for each of those trig ratios that they gave you, working within your different triangles. So as you can see, guys, it can get a little bit tricky when you're working in lots and lots of triangles. You need to identify your 90 degree, identify your hypotenuse, and then work out from there which side is your adjacent and which side is your hypotenuse. All right. Okay, and if you keep everything separated, you won't make a mistake. But it is quite easy to get caught up in which side are you looking at, which angle are you looking at. So keep it all maybe different colors or something like that, so it's easier to identify. Abraham, is it time for a break?
Yes, it is, Natasha. And having said that, I think it's highly impossible for you to do maths without Abram. You know why? Because you've been saying a lot of ABs there.
AB,
so
AB,
yeah,
yes. Lots of
But-
ABs in maths.
But I think having said that, we can do one last more question, don't you think?
Yes, well, if we've got
Let's
time
just do
before
one
a break,
question,
let's
yeah.
do another one. Okay, so building on from what we've just learned now, guys, is identifying opposites, hypotenuse, and all the rest of it. Let's do an application of this where we try to solve a triangle. Remember, as I showed you in the beginning, it looks quite simplistic now, but this is something that gets used in everyday life. Okay, so we asked to find the length of the unknown side in the triangle. This is question 2. And we've just got a triangle, doesn't even have any lettering on it. So I'm just going to call it, for the sake of keeping AB happy, we're going to call it ABC. All right. So we asked to find the length of the side. So we'll call our side here, which is CB. We know that we're looking for this little letter here, G. Okay. If you have a look at what they've given you the angle B. They've told you that that's 23 degrees. They've also given you the length of the hypotenuse AB as 32 degrees. Sorry, as 32. We don't know if it's centimeters or millimeters, not degrees, but just some measurements, okay? So we've got AB is 32. We know that angle B is 23 degrees, and we've got to find G, which is side BC. Now, if you look at what you've been given in this triangle, we want to work from all the information that we've got and see, well, what's the easiest ratio that's going to be able to help us out here, right? What are we looking for? What's the unknown and what's the known? So if I'm working from angle B, obviously we could find angle A, but that's going to be a little bit more work because now I'm going to have to subtract angles of a triangle and so on. So just working from what they've given you, can you find out the length of BC? And the answer is yes, you can, because we've got an unknown as our adjacent side to angle B, right? And we are given a known value as the hypotenuse side of triangle ABC. So therefore, unknown over known, adjacent over hypotenuse is cos of angle B. So therefore, I can say that cos of 23 is adjacent side, which is G, over the hypotenuse, which we were given as 32. So that means I've now set up a little trig equation which will help me to solve for this one here, to solve for G. All right? All we've got to do in order to get to side G, remember it's cos of 23 over 1, we can cross multiply. So therefore, I'm going to get G times 1 is just G, and that's going to be equal to 32 times cos 23, and all I'm doing is cross multiplying there to get G by itself. If you want to, you can go through finding an LCD and so on and finding changing the subject of your formulae, but this will be give you exactly the same answer. So G is 32 times cos 23, and we can do that on our calculator. 32 cos 23, and that gives me 29, 46. So 29,46 units of measurement, whatever it might be. That is the length of side G. Okay, so we know that G, or in this case BC, is going to have a length of 29,46 units, whatever the unit of measurement is. All right, so that was just a quick application of the concept of finding the solution of the sides of a triangle given your angle in the triangle. So here we had to find a length given an angle. All right, Abby.
Thank you so much, Natasha. Well, mindsetters, you know, we love giving. It is in our heart as mindset to give. So next week on Learn Extra Live, we're starting an awesome competition proudly sponsored by Casio. So make sure that you look out for that one. And you know, when we speak of Casio, something interesting and so cool is coming through. But for now, we'll see you after this break. Welcome back, Mindsetters. Now, I told you earlier on that you can get your notes on learn.mindset.co.za, but we have two new options where we're trying by all means to help you on. Firstly, it is the viewing option of the notes. If you don't want to download them, you can still view them as Natasha is going through them. Secondly, you can just download them straight away on the link that is posted on Facebook. So look out for those two options on our Facebook page. But for now, as we had a challenge question on Facebook, we're going to answer that one. Natasha?
All right, guys, so hopefully some of you have already gotten all the answers. There's 4 parts to this, A, B, C, D, and we were looking to find trig ratios without a calculator and by using a diagram. Guys, this is a really, really common test question. You'll see it in your homework and that. Make sure you can do it. Okay, and I hope some of you already have answers for us. Okay, Abraham will tell me just now. Okay, so here we were given the point A, which is -3 and 4. That is a point in the Cartesian plane. They say with the use of a diagram and without a calculator. So without a calculator means if you use calculators to find angles and that, you're not going to get any marks. Determine a sine of theta. All right. So what diagram are they talking about? What have they given us? All they've given you is a point A, -3 and 4. So we recognize this as a coordinate. That's x, that's y. So if I draw a Cartesian plane, which is what they asked you to do. Let's put that down. So here's my Cartesian plane. Remember, the centermost point is 0, 0. Okay. This point on my terminal ray, A, is -3, 4. So that point, I'm going to go from the center outwards. So we know that x is -3 and y is 4. Okay, so it's going to be a line that extends from the center, from the origin, to the point A, which is -3, 4. Now remember, when they give you those coordinates, your x value is -3. So if I have to drop a perpendicular height from point A, all right, and we were using pink there. So if I draw a line, a perpendicular line down to the x-axis, move that across so they actually meet. Okay, that's the diagram that they're asking you to draw. That's what they're saying. Okay, use a diagram and without a calculator. This is the diagram that they want you to draw there, right? We know that our angle here is theta. They tell you that. Okay, and they tell you that A is the point -3, 4. So if A is -3, 4, that means the x value at this point here is -3. Right? So therefore the distance from 0 up until that point is going to be 3 units. Also, we know that the vertical distance, so going from the origin all the way up, so going from the point 0 -3 going up, we know that that distance is going to be 4 units because the y value at that vertical point there is 4. Okay. So in terms of distances, what do we have? If my x value is -3, the distance from 0, 0 to this point where we drop the perpendicular height, that distance is going to be 3. But we don't know what the distance is from point O to point A. All right. Now remember, guys, we've got a 90-degree triangle, right? So therefore, if we have a 90-degree triangle and we've got two values, we've got the x value, we've got the x distance or the adjacent distance if we're looking at angle theta. We've got the opposite distance, again, if we're looking at angle theta. So we've got in units the value of the x, the horizontal distance, and we've got the vertical distance. So we know that x is 3, y is 4. We can work out the distance OA, which is our hypotenuse or our radius, by using Pythagoras, because we've got a 90-degree triangle. All right? So I can say x squared plus y squared is equal to r squared. We know that x is 3, y is 4. So therefore I'm going to get 9 plus 4, which is 9 plus 4 squared, which is 16, is equal to r squared. So therefore 25 is equal to r squared. So therefore your radius would be equal to 5. Remember, we exclude the minus 5 option when we take the square root because distance can never be negative. So therefore your radius or your distance OA is going to be 5. Why do I even need this? Well, guys, if you just try to go straight there and answer sine of theta, and all you've got is your adjacent and opposite value from your angle theta, you can't do anything. You need to have your hypotenuse. You need to have your radius so that you've got a triangle where you can work out your different ratios. So therefore, looking at my diagram and from this angle theta, we know that sine is, from our definition, sine is equal to opposite over hypotenuse. So therefore, sine is going to be 4 over 5. Sine of theta is 4 over 5. Once we've got this drawing and once we've got this triangle, we can very easily put in the rest of the values. Remember, we used the units, the 3 and the 4, to help us find our hypotenuse length, our radius length of 5. But the x value at that point, A, is minus 3. So when you're filling in these values for sine and cos and tan and so on, you need to use the values that you were given. Were they positive? Were they negative? Right? Tan of theta. So looking from an angle theta, I know that tan is going to be opposite over adjacent. So that's the same as saying tan is y over x. All right? So I know that the y value there is 4 and the x value is negative 3. So therefore the ratio for tan of theta is going to be negative 4 over 3. It makes sense, guys, that that is actually negative because you'll remember from working at different points in your Cartesian plane that your ratio for tan in the second quadrant, we call this the second quadrant. You guys will remember from doing this on different points on your Cartesian plane. Tan is negative in the second quadrant. And also just looking at the signs, x is negative, y is positive. Obviously, positive divided by negative is going to give you a negative answer. All right, then we look for sec of theta. We know that sec is the inverse or the reciprocal of cos. So therefore, sec is going to be hypotenuse over adjacent, or r over x if you prefer. So sec is going to be 5 over 3, negative 3. So sec would be negative 5 over 3. Right. Just by looking at this, if I said to you, so just looking at the fact that sec of theta is negative 5 over 3, if I asked you guys to then give me the answer for cos of theta without doing any work, it's actually really easy because remember it's just the reciprocal ratio. So therefore, cos of theta, if we needed it, would just be minus 3 over 5. Okay, so this is just an aside. You can work out the one from the other by using your reciprocals. All right, and hopefully a lot of you have already got the answers to parts A, B, and C. Okay, the last part, find sine squared theta plus cos squared theta. So from our diagram, and remember we've already worked out the value for sine theta, and now this becomes useful, the value for cos theta that we just got from our reciprocal. So here we're looking for sine squared theta plus cos squared theta. We know from part A that sine of theta was 4 over 5. So therefore I'm going to have 4 over 5 squared. We're going to square that entire fraction. Plus cos of theta, from what I've just shown you from our value of sec, cos of theta, if we just invert it, is going to be minus 3 over 5 and then we square that whole thing. Okay, if you didn't see that reciprocal, remember you can just go to your diagram here and say, well, cos is adjacent over hypotenuse, and put the answer down straight from there. All right, so therefore I'm going to get 16 over 25 if I square my sine ratio, plus minus 3 squared is going to give me 9 over 25. So therefore I get 16 plus 9, 25 over 25, which is just going to give me 1. Okay, so therefore just by using our triangles and the ratio, we've got that sine squared plus cos squared theta in that triangle will just give us a value of 1. Abraham, do we have some answers? Tell me some people got this right.
Yeah, there's one person who got everything right.
Well done.
Yeah,
Fantastic.
His name is Gledwin Muyaba, saying, yo, this used to be hard. I think he's doing grade 11. So he says it used to be hard in grade 10, but now he got the right.
Okay, so that's not fair, really. Hey,
It's
he's
not.
raining on the parade of the grade 10s.
Yeah, but some grade 10s really tried. I think for some it was the issue of, like on the first answer, most of them, I think they really got confused. They were saying minus 3 over 5.
The signs.
Yes, with signs. And second one saying 4. Okay, the second one, almost everyone got it right. So
Okay, so it was just a matter of working
and the last
out
one, almost everyone got it right.
the sine squared plus cos
Yes.
squared. I think it's because they know a little trick there. All right, well, I'm glad that the grade 11s are also paying attention, because it's good to do revision now of all the stuff you did last year, because you are going to need it going forward into the term. Are there any questions or anything at the moment, or can we carry on to our last?
There's a question that came through from Banyana saying, is it important to find all the answers of all angles in question 1, like you answered the bigger angle and smaller angle?
So we're going back all the way to question 1.
Yes.
And he's saying, let's just find that one. I think it was this page here. He's saying what? Is it important to find?
All the answers of all the angles.
To find the answer for every single angle. No, please don't do that. You need to answer the question that you've been given. So if you didn't even look at sine B and you then found sine B, cos B, tan B, but then they only asked you for sine B, you've wasted your time, especially in a test situation. If you're just doing it for practice at home for homework, fine, go ahead. The more practice, the better. But you don't need to write down the ratio for every single angle in every single triangle. I mean, that's a massive permutation. You won't have time to sit there in an exam and do that kind of thing. So if you work in the correct triangles and you know what you're doing, if you keep your head about you and work in the right triangles, use different colors in that, you won't get mixed up. So it won't be a thing where you're going to get mixed up if you don't write down from angle B, tan, sine, cos, then go to angle C, and then in each of the different triangles. That's way too much work. All right.
All right.
Okay, so hopefully that helped someone out there. Hey?
Hope so.
All right, so I think we can move on to question 3 in the improve your skills bit. Okay? So guys, a little while back when we looked at question 2, we were given the angle and we had to find the length of a side. Now in this question, we are going to be asked to find an angle, but firstly, we're going to need to draw our own diagram and then solve the triangle. Okay, so when you ask, later on you'll do 2-dimensional problems and that kind of thing. When you're asked to find any lengths and distances, and it's given to you in a word format, you would need to break this down, draw up a triangle, break it down to things that you are familiar with. Okay, and at the moment, the only thing you're familiar with is 90-degree triangles. Okay, so that's what your questions are going to be based on for now. All right. So let's have a look at the question and let's see what they want. They say you have a ladder of length 15 meters. So the length of your ladder is 15 meters. It's resting against a wall. The base of the ladder is 5 meters from the wall. And they ask you to find the angle between the wall and the ladder. Okay, so you can imagine what's happening here. You have a wall like that. And you then have a ladder that's resting against this wall. So let's draw a ladder in yellow. That's what your ladder looks like. And they're saying, all right, let's just try and get rid of some of these not working. Let's ignore them. I think that's going to be the easiest way to get around that. Let's ignore those little pink points. All right. So you've got your ladder is length 15 meters. So that's the length of your ladder. It's obviously lying against a wall. And they say the base of the ladder is 5 meters from the wall. So the base, so that's that point there. The base of it is 5 meters away from the wall. Okay, you can see automatically it gives you a triangle without you even trying to look for a triangle, right? So you know your length is 15. You've got the distance from the wall to the base of the ladder is 5 meters. They ask you to find the angle between the wall and the ladder. So where is that? Here's my wall. There's my ladder. So the angle they're talking about, that one. Okay, so they want to find the value of alpha. All right. Obviously, if you've got a wall, it's always going to be at 90 degrees to the floor, otherwise it will fall over, right? So we know that that wall is going to be at 90 degrees. We know that the distance from the wall to the base there is 5 meters. We know that the length of the ladder is 15 meters. Okay, so therefore, if I'm trying to find this angle alpha, I look in the triangle and say, well, hang on, what have I been given? Well, I know that I've got the hypotenuse, and I know that I've got the opposite. So therefore, from alpha, I can say, well, what ratio is opposite and hypotenuse? What does it relate to? Well, it relates to sine. So I can set up an equation. Sine of alpha is opposite over hypotenuse, so it's going to be 5 over 15. All right, then using your calculator, we can use the second function button and help us to solve for alpha. So I start by saying shift sine of 5 divided by 15. And that gives us an answer of 19,47. So therefore, our alpha here is 19,5 degrees if we round that off. Okay, so that's the angle that the ladder there is making with the wall. Okay. All right, so we've covered quite a bit today, guys. I hope you have gotten this far at school, and if not, I hope that you've learned something new. I'm going to cross over to AB to see if there's any last-minute questions before we say goodbye.
All right, there's no question, Natasha, but however, I just want you to help the grade 10s. They're just coming back to the new terms. What are some of the tips that you think will work out for them in terms of focusing well on this term, especially those who didn't do well on their first term?
Yeah, guys, I mean, it's really hard to just put it all behind you and to just move on. But that's really what you have to do. So forget about the first term. Yes, you need all of that work. You've got a lot of holiday time coming up. Use that to revise and study all the work that you didn't understand. Get some help from your teachers. Get help from your peers. And make sure that the work you didn't understand, you can sort that out in the holiday. The holiday is really the perfect time to catch up. And once you've got those basics, because maths unfortunately does work like that, you need to sort out the basics. You can't just leave it all behind you and carry on. No, you do want to carry on. You don't want to focus on the bad stuff, but you need to sort those problems out. Okay, so try and forget about the bad marks, but don't try and forget that you actually need to still sort those problems out. So don't forget, just go back, revise, revise, revise. The holiday is perfect time to revise, and hopefully term 2 is going to be much, much better where you can put everything together.
So true. Help is always out there for people. But for some people, they always say they can't work in groups, because I believe that when you're doing a subject that is like mathematics, it needs you to get help from other people also. What is your advice on people that say they can't work with groups?
It's actually a tricky one, because I myself find it really difficult to work within a group situation. So I know that it is possible to get good at maths without having to work in a group situation. But at the same time, you do need help from your friends. You do need help from your peers in order to get better in some sections. But remember, if you're uncomfortable working in a group, you can always just ask your teacher or ask us at Mindset, and we'll be more than willing to help you if we can. All right, but you don't have to work in a group to get better at maths, but it does help to share your problems sometimes.
So true. Thank you so much, Natasha. We really enjoyed the lesson today.
Pleasure, pleasure. Thank you so much for joining us, grade 10s. Thank you, AB, for being here. And What's been the conductor of the show.
Thanks, you're really saying I should do physics tomorrow. But anyway, thanks to you, Mindsetters, for tuning in. And remember, help is always there for you. Our website is there to help you, learn.mindset.co.za. That's where you get all your notes. But otherwise, we have an application, our help desk on Facebook. The link is on Facebook. We love you so much. And great times, all the best for this term. Peace.